So we have joining us Chris Holzapfel, who is the research manager for IHARF, the Indian Head Agricultural Research Foundation. And they focus on a broad range of agronomic issues and crop types and focus mostly on applied research then and helping develop practical solutions for today's farming challenges. IHARF is a not-for-profit organization funded by a combination of government, producer, and industry sources whose mission is to promote profitable and sustainable agriculture by facilitating research and technology transfer activities. And so today we have Chris here to give us an update basically on a lot of the applied research highlights of what they've worked on in soil fertility at IHARF. So welcome, thank you for joining us.
Thank you. Just bear with me 1 second. We'll get right into it. I've got a lot to cover here. That's not my fault. John gave me a whole wide spectrum of topics to cover here, and then he even threw in one extra one just to basically at the last minute. So we're going to move pretty quickly. As Marla said, we cover a lot of different crops, a lot of different topics, but a big percentage of that is always soil fertility work. And that's certainly one of my strongest interests as well. And that's going to be what we're going to focus on today here. So this is just a list of what we've got for, I guess, different, I'm just going to hide this. What we've got for different topics. I'm not going to read everything, but we will go through and you'll have a chance to see some of the results as we go and some of the data, some of the work that we've done. But you can see quite a range of topics here that we're going to get through. So a big part of what we've been doing the last 4 years here, these are really just demonstrations, but it's been through the ADOPT program, which is part of the provincial government of Saskatchewan and the Canadian Agricultural Partnership. But we've really just been trying to do some fairly basic demonstrations of the 4R principles in nitrogen management in particular for what I'm going to show you here. And this dates back to 2017, and I'll just mention that in the first couple of years of this work, we did do it with canola as well, but our results with canola always paralleled what we saw with spring wheat. And I like spring wheat as a test crop just because we can look at both yield and then also protein, of course, which is very responsive to nitrogen and also an important grading factor for the wheat. So we'll just kind of go through it 1 year at a time. The treatments themselves have kind of changed a little bit from year to year, but the premise has been the same, and they share a lot in common. So hopefully it's not too hard to follow along. So this is what we did in 2017. You'll see with every year pretty much, we always have a little bit of a nitrogen rate component just to see what the overall response to nitrogen rates looks like. And then from there, we take our 1x rate and evaluate a bunch of different management practices, if you will, where we're varying the form, the placement method, the timing of application, things like that. And those are really the things that have varied year to year. So I'll also mention that 1x rate, we always purposely made that just slightly lower of what I expected to be optimal in any given year. We didn't want to apply too much nitrogen, or we felt it would be too difficult or impossible to pick up differences in efficiency of the different management strategies. So we always did keep our N rates fairly modest. They're adjusted for soil residual nutrients, and you can see that we were looking for 116 pounds N per acre total nitrogen. So that's fertilizer plus soil. I guess if we just go through our treatments here, side banding of untreated urea, that's kind of always our golden standard. That's what we're, trying to not necessarily beat, but at least do, about as well as with some of our other practices. We had a whole series of treatments here where we did a pre-seed surface broadcast of nitrogen. This was done in the spring because this year we only got funding in the spring, so we couldn't have any fall treatments. But we had a few different products there. Again, our untreated urea, UAN or liquid 2800, agrotane treated urea or super urea. In addition to that, we did a split application. So for that, we put down half of our nitrogen as side banded urea and a little bit from our 1152 and ammonium sulfate. And then the remainder was topped up in crop. For the wheat, it would have been an early stem elongation, kind of mid-June application timing. And that was as one of these different forms here. So again, urea, UAN, agrotane, or super U. Our responses from 2017, and I'll have a figure like this for every year. You can see pretty nice, strong response to yield response to nitrogen. There's our 1x rate, so we're at a good spot of the curve to be. And this is our protein response here, which as expected, in this case, it's almost linear, but we always expect to see protein continuing to increase to higher rates of nitrogen than yield. Basically, yield has to get maximized, and then protein will continue to climb usually for a little bit after that. When we looked at our wheat yields from 2017, everything looks pretty good here. A little bit of variation, but no statistically significant differences amongst the different treatments. This is all the same rate of nitrogen, just applied in a different manner. So the green bar here is our side-banded urea. These are our pre-seed applications. These are our split applications. And I can't get into too much with specific weather in any given year, but we'll touch on that later. Protein was a little bit of a different story. You can see here, we actually do have a clear winner, and that winner is our side-banded urea. Urea is the only product that we side-banded in this year, but despite the yields being similar for all of our other products, you can see that we certainly were losing some nitrogen out of those practices, or at least not getting it to the crop, because it did come at the cost of lower protein. And it didn't really matter how we applied it. I mean, if we want to pick on a treatment, our entire, when we applied all of the product as urea as a pre-seed surface application, that was our worst. But, relatively few statistically significant differences here. There are some, but the important thing I think is that none of them get up to where with good old side-banded urea. 2018, we switched it up just a little bit. So we've got our same rates, our control half rate, 1x rate, and 1.5x rate of side-banded urea. But in this year, we also side-banded some of our other products. Now it was Agrotane, Super U, and actually ESN, a polymer-coated urea. We had a fall surface broadcast application. We didn't include the ESN there, just kind of under the realization that ESN isn't an ideal product for surface applications in a dry environment. And we had to keep our number of treatments down to a manageable level. And then we also had a fall in-soil band, and those were applied at the same date, the fall surface application and the fall in-soil band. And there we had all of the different products, including ESN. Those would have gone down. I don't have the exact date listed with me, but they would have been right around mid-October is usually what we were targeting there. Here's our yield and protein responses again. So not quite as responsive as what we saw the previous year, but still pretty good. You can see our 1x rate might mask some differences in efficiencies there, but when it comes to protein, we're in not a bad spot where if we do start losing some efficiency, we should be able to pick it up. So here's our wheat yield here. Again, actually everything looks pretty good right across the board. Our highest numerically treatment is the fall banded ESN, which would be certainly a good practice, but very few statistically significant differences amongst the bunch. When we look at the different forms, within a placement option, really no significant differences there, and all of them look comparable and pretty good. Once again, we do get a little bit more separation with protein though. So we've got, I did do some contrast comparisons, I guess here, group comparisons, if you will, and side banding overall was better than the fall in soil band, was better than the fall broadcast application. So pretty much exactly what we would expect. Within any given application time / placement method, there were really no differences between forms that were statistically significant. So once again, the side banding does have the edge, not quite as much though in this year. But again, we weren't quite as strong a response to nitrogen either. 2019, we switched it up again. Every year we kind of tried something new, which creates some challenges for combining data, but also they were all, interesting methods that we thought were relevant. So we did expand on the number of rates that we evaluated. So finer intervals, I guess, between rates, and we went up a little bit higher, up to the 1.75x rate there. And then on top of that, we had a few different placement methods. So again, side banding of all of our different products, a fall surface broadcast application, and then instead of the fall in soil band, we went with a spring surface broadcast application. So same method of placement, but different timings there. I've got the dates just listed for your interest. Here's our response to nitrogen. You can see where our 1x rate is there, so it's a pretty good place to be. And these are our wheat yield responses. So in this case, I was able to analyze this as a full factorial, and forms were not significant, and there was no interaction between forms or the timing / placement. but we did have the best efficacy with our side banding once again. And then both our spring and fall surface applications performed similarly when it came to yield specifically. When we look at protein, we get a little bit further separation. So still no differences between forms, no interactions between form and timing or placement methods, but our sideband treatments are certainly the winner here, followed by in this case here, the spring surface application did do a little bit better, and the fall application was the lowest protein of the bunch. Those can flip around a little bit sometimes, just depending on timing of precipitation and what exactly happens on that field. In theory, the spring application should be better just because it's going down closer to the time of peak crop uptake, but environment also plays a big role here, and that might not always be the case. 2020, just this past season, this is still preliminary. I'm just writing up the report right now, but we switched it up again a little bit more, and we're actually repeating this exact protocol here again in 2021. But we've got less emphasis on rates now. So here we've got our control treatment again, as always. We do have a high N rate, and that's for both products. We had two products here, urea and untreated urea and super urea, which is both a urease inhibitor and a nitrification inhibitor. And then we had everything else was just our 1X rate again, once again. So we actually backed off a little bit more here, only 98 pounds N per acre soil plus fertilizer at our 1X rate. But we did a few different things. We side banded that fertilizer. We had a fall surface broadcast application. We had a spring surface broadcast application, so similar to what we did the previous year. And then a couple more fall treatments that went down the same time as that broadcast application. And there we had a deep band where we set our Seedmaster drill as deep as it would go. That'll get that fertilizer down about just over 2 inches, 2.3 inches is what I had estimated as the actual depth. And then we had a fall shallow band where we were trying to get that fertilizer at about a 1-inch depth. And these are fall applied treatments in a 2-pass fertilization seeding system. But I think you could also draw some inferences with this banding depth to side banding as well. So for example, if you had a drill that placed the fertilizer at the same depth as the seed, with shallow seeding, you might end up somewhere in this range as opposed to down here, which would probably be more optimal. Just looking at our yield, there's our control, of course. Really no differences between the two forms under the conditions that we had. But there were some differences between treatments. So of course, our 1.5x rates, they stand out as being the highest yielding of the bunch, which is what we want. Our side banding then does tend to fall second in line there, performs quite well. It's the one to beat regardless of what form we use. Our surface applications, whether in the spring or the fall, both perform relatively poorly, at least under the conditions that we had this past season. And then our fall in soil bands were both quite a bit better than the surface applications, maybe not quite as good as side banding, but look pretty good overall. But they were definitely an improvement over the surface applications. This is a look at our protein. So, I guess as you would expect, our high N rates are by far the biggest protein. But if we focus on our 1X rates, you can see once again that the patterns are very similar for the two different products that we used. They do favor side band placement, which is generally better than both of our fall in soil bands, which are in turn, for the most part, better than our surface applications. So it's really more or less what we would expect. I realize I'm going through this very quickly, but I guess, one thing that will benefit you is our PDFs of the slides are available. I would encourage you all to download those if you want to take a closer look at these things in the future, and then you'll be able to really take your time with some of the figures. I'm going to move on to a new trial that we did. This is something that we finished up fairly recently, just in 2018 was when we wrapped it up. And we really just wanted to take a closer look at safe rates of side banded 1152 for a few locations in Saskatchewan relative to, safe seed placed 1152, and then look at the response to that relative to side banding and some other treatments. So these are our locations. We had Scott, Indian Head, and Melfort, all in Saskatchewan. Ran it over a 3-year period. We had 5 phosphorus rates and essentially what we would call 3 placement methods. Those were seed place, so in furrow. The seeding equipment varied a little bit, but was all comparable. We used a Seedmaster again here at Indian Head. Here's our side band treatment, which gets that fertilizer both below and to the side of the seed. And then with our seed placement, we tried just adding a little bit of ammonium sulfate to make the blend a little bit hotter, I guess. So that was 54 pounds per acre of actual product to supply 13 pounds per acre of S in the seed row. I'm not going to go into detail on this slide, but just looking at, I guess, some of the sites, very general characterizations. They would, organic matter, percent clay, and soil moisture will generally increase as we go from Scott to Indian Head up to Melfort. And with that, the risk of seedling injury should be declining in theory as we go from one site to the next. And that's really exactly what we saw. I'm going to show you some data for Scott first. This is averaged over the full 3-year period here. But what it shows is that with side banding, we could apply as much 1152 as we wanted to, really. It didn't matter. It had no impact on emergence, even all the way up to 71 pounds actual P2O5. So that's just shy of 140 pounds of product there. No impact on emergence. When we seed placed, remember this is specifically at Scott, we basically started losing plants, right off the bat. Even at 18 pounds per acre, we did lose a few plants, and that just continued on linearly as we went to the point where it was, pretty substantial loss at those very high rates. When we added ammonium sulfate to the mix, you can see that we knocked off a few plants right off the bat. For the most part, we always had more plant loss than we did with 1152 on its own, which is exactly what we would expect. But when we got up to these really high rates, it didn't really matter too much. It didn't appear to, but certainly if that ammonium sulfate could be not put in the seed row, that's going to help with seed safety, which is what we would expect. Indian Head, things looked a little bit different. So once again, we do have, really no impact at all on emergence with side banding. That was safe even at the very high rates. Seed placement, when we were at this 18 pounds P2O5 per acre, really no impact there. But as we continued to increase, we were knocking off some plants with each increment as we started to add more and more fertilizer. Not too much difference really with and without that ammonium sulfate, but for the most part, we did see a higher number of plants being lost when we had that ammonium sulfate in the mix. Interestingly, at Indian Head, even though we were losing plants, we very rarely actually fell below what would be considered a critical threshold where we might expect yield loss to occur. So we are losing plants, which we don't want to, but not necessarily to the extent that the field would look real bad or we would expect to have a yield loss. Where at Scott, we did lose plants to the point where we would expect yield loss. This is just a nice visual of some plots at Scott here that kind of show what we were measuring in numbers. So this is all the highest rate of 1152. And you can see here our side band stands look pretty good. Seed placement, definitely more variability there and lower numbers overall. And when we threw that ammonium sulfate into the mix, that's when things start to look really bad. Looking at our yield responses here, this is at Scott. We had potential to get some really nice responses to phosphorus, but placement mattered. So at the lowest rate of P, which wasn't enough to maximize yield in this environment, it didn't matter how we placed it or whether or not we put that sulfur in the seed row. We had a similar response all across the board. We were losing a few plants, you recall, but not enough to have much negative impact. At the 36 pounds P2O5 per acre, without the ammonium sulfate, the yield response looked pretty similar. When we had that ammonium sulfate on top of the 1152, there we were starting to see a bit of a negative impact on our response, and that's due to losing plants. And as we go up, it gets worse and worse. And at this highest rate here, 71 pounds P2O5 per acre, we've essentially lost all potential benefits of the enhanced P fertility because of the large number of plants that we've essentially lost. At Indian Head and Melfort, the placement really didn't matter. We got a similar yield response to phosphorus, regardless of how we applied that fertilizer there. The response to phosphorus did vary a lot from location to location, and that's not necessarily too surprising. We had a couple locations where 2 out of 6, I guess, where we had no response to phosphorus at all. We had one location in Melfort where they had a 16 bushel per acre gain against the check. And then of the responsive sites, the weakest response was Indian Head 2018, where we only had about a 2 bushel gain relative to the check. And on average, we gained 4 bushels per acre. Moving on to something new here. This is a fairly recent project here. It was initiated by the Saskatchewan Pulse Growers and funded by them. And we ran it at multiple agri-arm locations and really just wanted to revisit field P response to kind of a wide range of macronutrient applications. So we looked at nitrogen, there's a little bit of nitrogen fertilization, but a big part of the focus was then on phosphorus and sulfur. These are our treatments. You can see it is pretty busy, but they were selected carefully to allow us to independently evaluate, I guess, our response to phosphorus. Those are the different rates there in the red, 0 all the way up to 71 pounds P2O5 per acre. All fertilizer side banded in this, I should mention, except for some of the nitrogen, which we'll touch on. For sulfur, we've got rates ranging from 0 up to 13 pounds actual S per acre. So 0, 4, 9, and 13 pounds S. And then with some of the nitrogen treatments, we did a few different things here. So in one treatment, we just side banded all of that extra nitrogen as urea right at the time of seeding. We had another where we applied that extra nitrogen as an in-crop broadcast application, again, of urea, and that went down just kind of prior to flowering, after herbicide application, prior to fungicide application, kind of in there. We tried to get out before the canopy closed too much, and we'd start to cause some collateral damage. We had another treatment where we put down ESN instead of urea. And really the rationale behind these two treatments was to maybe get a lot of that nitrogen supplied a little bit later in the season when it was less likely to have a negative impact on nodulation. And then I guess the two extremes that we had there were our no fertilizer. So everything was inoculated. I should add that. It all received a label rated granular inoculant. No fertilizer whatsoever. And then what we called our ultra high fertility. And that got, it got the nitrogen as ESN, the biggest rate of phosphorus, the biggest rate of sulfur. We did leave potash out of this trial entirely, largely for simplicity. None of the sites were calling for potash, and it got too wild with everything else that we were trying to do, so we kept it out of there. In terms of locations, you can see we do really cover all the soil climatic zones of Saskatchewan and have a good range there. So from Swift Current, which would be in the dry brown soil zone, generally our lowest yielding location and by far the driest, coarsest textured soil, right up to Melfort, which would be in the moist black zone, high organic matter, usually higher background fertility, things like that, higher moisture. So this is averaged over all 6 locations in 2019, and just a look at, I guess, all 13 treatments here. It's pretty busy. Don't necessarily strain too much over trying to interpret. When I look at this figure, the one thing that jumps out to me right off the bat is our no fertility treatment is definitely the lowest yielding. And you can see right here, these are our phosphorus treatments. So you can see a pretty big response to phos kind of right off the bat. Not much else going on in terms of the sulfur fertility, the extra nitrogen, things like that. And I guess notably, on average, when we applied 18 pounds per acre of P2O5, there was no significant, that was, at least as far as the statistics go, as high as any other treatment in the bunch here. But it did appear to keep climbing a little bit, where maybe that 36 pounds actual P2O5 per acre was perhaps a bit more optimal. If we break this down by, I should just mention, we do have a fertility by location interaction, which tells us that the response did vary for individual locations to some extent. So if we break this down, we'll look at phosphorus first. You can see pretty good responses to phosphorus for the most part. We had all locations except for, I guess, Yorkton was really the one that kind of stood out as not being responsive to phosphorus. But other than that, all of the sites did, there's at least evidence of a positive yield benefit to phosphorus. If we look at sulfur, that was, if you recall from the first slide where I showed everything, it didn't look like there was much going on. And we see that to be the case here as well. There is some noise maybe with some of these treatments, but really the only site that looked like a positive response to P was at Yorkton there, or sorry, to sulfur, I should say, was Yorkton. That's this location right here. Extra nitrogen by location, really no indications of any benefits to that extra nitrogen. If anything, we had a couple that kind of popped out as being slight negative impacts when it came to yield and that extra nitrogen, but certainly no benefits and nothing that would justify making that recommendation. We were also really interested in protein, just I guess with some of the emphasis on plant-based proteins in terms of, the human diet. We figured there might be extra marketing opportunities or perhaps even premiums associated with high protein peas. So we were interested in this, looking at all the treatments by all the sites, really no impact at all of fertility on the different on protein levels. And that held true for the most part when we looked at individual locations as well. In fact, the only one that popped out was here at Scott. There was some evidence of extra protein with that extra N, but it was most evident when we side banded everything. And from the previous slide with the yields, that treatment actually had the lowest yield of the bunch. It looked like we had a bit of a negative impact on yield, so still not something that we would recommend. We did continue this trial in 2020, so this is just a little preview of what we had from Indian Head. Stay tuned for results, I guess. But when I look at Indian Head 2020, it looks like, again, we've got that good, strong response to phosphorus happening, and maybe even some benefits to some of this extra nitrogen fertility. We'll see what comes out in the more sophisticated analysis. There was reasonably high background fertility here. I think we had about 30 pounds in the top 2 feet of soil, but it was very dry through May and June, into July. The whole season was really dry, so it's possible that maybe that had some impact on nodulation or nitrogen mineralization too, but I don't want to speculate too much. When it came to protein, not much going on there. Moving on to flax. So this is actually another fairly recently concluded project. In 2018, we had lots of different funding agencies there. That's the Ministry of Agriculture in Saskatchewan, Flax Development Commission, and the WGRF as well, all funded this work. We basically looked at 4 combinations of different nitrogen rates and phosphorus fertility rates. So when it came to nitrogen, we didn't actually have a zero. This 12 pounds per acre is what we got from our highest rate of phosphorus with the 1152. And then we went up to 135 pounds per acre actual N. These are not adjusted for residual soil levels. For phosphorus, we went from 0 up to 53 pounds actual P2O5, 0, 18, 36, and 53. 8 locations over a 3-year period. So they were mostly in Saskatchewan, but we did have one in Manitoba, which was Brandon, and we also had one in Vegreville, Alberta. Our residual nitrate ranged from 7 to 93 pounds at NO3 per acre with 40 on average. That a little bit higher than what I would have liked to see, but it is what it is. Our Olsen P levels, we did pretty good when it came to phosphorus. Basically, 84% of our sites had Olsen P levels below 11 parts per million. And 95% of the sites, those values were below 20 parts per million. Averaged across all sites, we were down at only 8.7 parts per million. So good potential for a P response. Just what it looked like at those individual locations. So I've highlighted what I would call low P sites, and also what the sites that had higher residual nitrate than we would have liked to maybe see. So first we're going to look at emergence here, and I'll just say I don't show you the busier statistics, but phosphorus had no impact on flax emergence regardless of the rate. And again, this fertilizer was all side banded, nothing was seed placed. So I don't think I mentioned that previously. So we didn't necessarily expect it to have much impact on emergence. Urea did though, and this wasn't necessarily unexpected. There are precedents in past research that showed the same thing, but it was pretty consistent. At 14 out of 19 of our sites, they were picked up as showing a highly significant reduction in plants with increasing nitrogen rates. And this is again side banded urea. So this is that line right there. You can see it's a pretty strong, just linear drop. I did highlight the 300 plants per meter squared here on the graph, just because that's kind of what we look for a minimum plant population with flax, where yield and maturity, things like that, aren't likely to be negatively impacted. Even our non-responsive sites were a little bit responsive, but just not to nearly the same extent. But you can see with our biggest rate of nitrogen, we actually still were significantly lower than the control or some of the other treatments there. Moving on to yield responses. First, we'll look at nitrogen. And for the most part, as we would expect, we did see positive yield responses to nitrogen rate. It did vary by sites, and actually, you know, when I did the stats, 3 of those sites were identified as non-responsive, and the 15 out of 18 there were identified as responsive. You'll notice there aren't 24 sites just because I often had to knock a few out for various reasons, whether they were, you know, just different issues that we had to remove some sites from the analysis. Focusing on our responsive sites, though, basically we, you know, pretty strong responses to N, and it looks like things were kind of increasing up to about that 90 pound per acre mark and then leveling off from there. Our non-responsive sites, again, we're still a little bit responsive, but not nearly to the same extent. And also importantly, you know, we only needed about 45 pounds of nitrogen to get really all the benefit that we were going to get. This is just a peek at some of the individual sites here, really busy, but you know, this is just what those responses look like. And you can see that it does vary a little bit from site to site, but for the most part, you know, between about 75 and 110 pounds of actual N per acre is where things are optimized. When we look at our non-responsive sites, this is what it looked like. And we can explain all of these really either by high residual N or other factors being major yield limiting, I guess, factors, or a combination of both. Phosphorus. So flax is known to be, I guess, not the most responsive crop, but we did see some actually a pretty good response to phosphorus in this trial as well. There was no interaction with sites, interestingly enough, so this was fairly consistent, even though it was quite modest. And the response was actually linear, but I cheated a little bit and put a curve in there because I think, you know, it was realistically leveling off at these more modest rates as opposed to all the way up to the biggest rate of P205. This is what that looked like for individual sites. And, you know, as I was carrying through with the interim reports actually and looking at these individually, a lot of those responses weren't strong enough to even pick up and call significant. But when we brought everything together for a combined analysis, which has much more power, they did pop out as being significant. And again, with actually no interaction, which told us that it was quite consistent, even though it wasn't real strong. Yield response to P at varying N rates. Yes, there was actually a nitrogen by phosphorus rate interaction when we looked at all the sites, and it was pretty straightforward. Really, all it told us was that we needed to take care of the nitrogen before phosphorus became important. So at our lowest nitrogen rate there, not much of a phosphorus rate, where you can see when we start adding the nitrogen to it, we do need a little bit of phosphorus to optimize yield. Winter wheat, I wasn't sure how much interest there would be in this, but it does complement some of Ken's actually presentation there before. So I've just got a couple of site years of data that I wanted to show you, and it's the emphasis is just on nitrogen rate and then some different placement timing options. And we kept it pretty simple. Basically, we had 5 different N rates here. So from 53 all the way up to 160 pounds actual N that is adjusted for residual soil nutrients. And it was applied either as a 100% sideband application, so all at seeding in the fall, 100% early spring broadcast application, or a 50-50 split where half the nitrogen went down in the fall, the other half in the spring. Our growing seasons were pretty similar. We had, I guess in both years, it was dry overall, I guess throughout, so I will mention that right off the bat, but in both years, we did seed into enough moisture to get that crop off to a good start. And you know, I won't comment, I guess, on what that means for the nitrogen, but basically got the establishment going right off the bat. We had a good crop get started. With the spring broadcast applications, they were dry seasons, but we always had some rather timely, I guess, precipitation events. So in both years, within 24 hours of application, we had 5 to 6 tenths of rain, and usually a little bit within the week. I guess if we look at the growing season as a whole, 2019 was 61% of the long-term average. 2020 was 46%, so a little bit drier this past season. Here's our response curve. So yield, looking at 2019, looked like all placement methods were virtually identical. Good responses, they all performed well, and responded to some pretty high rates. They're leveling off at around 110 soil plus fertilizer. When we look at our protein there, you know, you can see we do respond to higher rates, and we do get a little bit more treatment separation. These actually favored the spring broadcast application and the split applications. 2020, things were a little bit different. When it came to yield, our best options were sidebanding everything and the split applications, where we did have a little bit of a yield drag there with our spring broadcast applications. And actually the split applications were intermediate as well, with fall side banding being the best. For protein, things flipped around though, where we basically saw the lowest protein levels with fall sideband, followed by the split application, which didn't significantly differ from fall sideband, and then the highest protein with the spring broadcast. You might attribute that largely to dilution, but I think a big part of it is maybe that spring applied nitrogen wasn't entirely lost. You know, some of it might have been lost, but just its availability was shifted a little bit later into the season, where it, you know, maybe didn't get to the crop early enough to prevent all of our yield loss, but was still there to help support the higher protein levels. Soybeans, you know, a Saskatchewan boy has no business telling Manitoba people how to grow soybeans, but I thought this was something of interest anyways, a fairly recent project that we wrapped up just in 2017, looking at inoculant and responses to N fertilization. So these were our treatments, or well, first our locations were Indian Head, Outlook, and Melfort, all kind of wetter regions, and then Outlook actually had the ability to irrigate there. For inoculant treatments, we had our liquid only, so we call that single inoculant. All of these treatments did at least receive a liquid seed applied inoculant, 1x rate of granular, 2x, and 4x, so some big rates of granular inoculant. When it came to N fertilizer, we had no supplemental N fertilizer, so we got a little bit from the MAP, but nothing else. 50 pounds N per acre, all as side-banded urea. 50 pounds per acre as side-banded ESN, where similar to the field peas, we were just hoping to shift that availability a little bit later into the season, where it was more likely to be beneficial without the negative impact on nodulation. And then 50 pounds per acre as a dribble-banded UAN we used, and that was at the early pod filling, or R3 stage. All locations had no previous history of soybean production, except Outlook in 2016, which was our third soybean crop in 7 years, and I analyzed that separately. So first, this is our sites with no soybean history whatsoever, and the results are pretty interesting. You can see right off the bat a pretty big benefit to the dual inoculation. When we had good inoculation, there was no need for nitrogen fertilizer, regardless of how we applied it. But when we had, you know, let's just call it a nodulation failure or poor nodulation, then we did see some benefits to the nitrogen fertilization. Importantly, it never got it up to, you know, what we could achieve just with good nodulation in the first place. Of these, the one that would make the most sense would be that in-crop application, because I would consider it more of a rescue application. But I would avoid UAN. You know, this is something John mentioned to us when he saw the plots, but we did see a lot of leaf burn sometimes, which probably negated or, you know, took away some of the potential yield benefit. That's just visually what it looked like there. So this is Indian Head in 2015. You can see liquid only versus with the granular. Here's Outlook 2016. Remember, third soybean crop in 7 years, and really not much benefit to the dual inoculation at all, or the nitrogen fertilization. So you can, you know, it doesn't matter, I guess, quite as much what you do there. I would never recommend not inoculating, but there's certainly no need to, you know, get carried away with going beyond label recommended rates or multiple different products. Last topic here. So this was just kind of a final add-on, and I won't take up too much more of your time. But this is actually some work that we did quite a while ago, back in 2012 and 13, but it was just published this summer here. So it was looking at crop uptake of sulfur from some very specially formulated fertilizer products, where our sulfate S and elemental S were labeled with some 34S isotopes. And what was important about that is we could actually track the applied S in the soil, you know, and through the plants right into the grain, and see what forms of sulfur the crop is utilizing. And this was truly an international project. We were the Canada site, obviously, but we also had a site in Argentina and Brazil. And the project was headed up out of Australia, Mike McLaughlin's research team with the Fertilizer Technology Research Center in Adelaide. They were really the leads and did a lot of the analysis work for this project. Just a quick look at our environments here. Argentina, well, Canada down here is by far the coolest and the driest. Our products and crop rotations reflected the regions. In Canada, we used MES 15, and it was a canola spring wheat crop rotation, or crop sequence, I guess would be more appropriate. Argentina was kind of intermediate there, still just 2 crops. They grew corn and soybeans. And then Brazil was our real tropical environment there, and that was our warmest, wettest climate. They double cropped in each of those years. So soybean and corn the first year, soybean and corn again the second year. When we look at crop uptake, this is quite interesting. So first, let's just focus on Canada here, and you can see that that first year of application, virtually all of the S that the crop is taking up is in the form of sulfate S. It's not accessing that elemental really in that first year of application at all. This was placed in furrow here, so it's not like a surface broadcast application that we might do with some of our elemental S products. In the second year of application, we did start to see some of that, more of that elemental S becoming utilized there. So it wasn't lost, it just takes longer to get available for the crop. The polar opposite here is Brazil. And you can see for them, they actually lost a lot of that. Well, they didn't apply as much sulfate to begin with, but it has a lower efficiency and was largely attributed to leaching just in that warm, wet environment where things were a little bit more intermediate in Argentina. And with that, that's my last slide. I hope I didn't take up too much of your time. I know I went through things really quickly, but I guess what I really want to, ask of you is if you're interested in seeing more about some of this work, just go to our website. Everything's available in reports, posted presentations, fact sheets, that kind of thing. And we'll continue to update that as you go. And there's my contact info as well. I always welcome people, reaching out by email or phone, or I'm on Twitter. So however you want to get to me. With that, I will end it.
Perfect. Thanks, Chris. There's a couple of questions that have come in. So one is going kind of back into the presentation on your canola phosphorus study. Were you able to explain the variability in phosphorus response with the soil test P levels?
Probably not as well as we would have liked to. I would have to go back and really kind of look at the report in more detail to answer that with a lot of confidence. A lot of those sites were, at least moderate levels of phosphorus. Indian Head was one of the lowest, but I would say to a certain extent, but probably not as well as maybe we would hope. I know that's a pretty vague answer.
The nitrogen rates that were applied to flax, what was that total nitrogen, soil plus applied, or just applied nitrogen?
That was just applied nitrogen. In that particular case, we did not adjust things for residual soil nutrients. We do have all that information. It's available in the slideshow as well for your interpolation, and then also in the full report. But the rates that we applied were, at the maximum rate, 155 pounds per acre actual nitrogen, okay, plus residual soil.
And then the last question we have here is what's the row spacing on the Seedmaster that you're using?
It's actually a kind of a neat drill where we can vary the row spacing from 10 up to 16 inches, but our go-to row spacing and what we used in all of the trials that I present today was 12 inches or 30 centimeters.
Another one popped up. Was the phosphorus seed placed or mid-row banded in the flax study?
Good question. All of the fertilizer was intended to be side banded at that low or in that trial. So for everything that I showed you, the P was all placed in the side band. We didn't seed place anything in that study. We had to keep it simple. Vagreville, unfortunately, they actually mid-row banded all of their fertilizer. So I ended up excluding it from a lot of the analysis just because we didn't feel that was an appropriate way to apply 100% of the phosphorus.
Yeah. And another question came in. Did you consider soil pH when you were choosing your fields?
No, they're really just all kind of on the plot land available to the different locations, but should be reflective of the regions. For Indian Head, for example, our soil pH is very consistent and quite high, probably comparable to what you guys see in Manitoba at many locations, but we're usually anywhere from about 7.8 to 8.1 for that top 6 inches.
Perfect, thank you.
It's always reported, but not something that we necessarily seek out variation in.
Yeah, well, and that's always good. And the fact that you are presenting a lot of information at us today, probably people are still writing notes. But the fact that you have all of this stuff compiled at the iHarf site is and available for people to see is also very beneficial. So everybody can still see your contact information. And so thank you, Chris, for being with us this afternoon. Round of applause. Yes, thank you. I really appreciate the time that you took to compile all of that information and present that to us today.
Oh, it's my pleasure. Great to be back. It's been a few years since I've been at this conference, and hopefully
Yeah,
I'll
well,
get
back,
invited again.
virtually back, kind of, exactly. We welcome you anyway. We can get you. So thanks a lot, Chris.